Hello students, this is lesson U2A02. In this lesson I am going to go over exercise U2A02a. And in this lesson we are going to go over how to describe the transformation of y equals x squared, which is the parent function for the quadratic equation. And in addition to this, we are going to look at how we can write a quadratic equation into vertex form and graph quadratic equations in vertex form. So let's take a look. Example 1. This is taken out of the Algebra textbook, the Algebra 2 textbook. This is taken from page 322 of our Algebra 2 text. And what we're going to look at is we're going to analyze, for question 1, we're going to analyze y equal to x plus 2 squared plus 1, and then we're going to draw its graph. So what do they mean by analyze? Well, what they want us to do is they want us to describe, well, how is the original parent function y equals x squared going to be transformed with when presented in this manner here. So now I have x plus 2 quantity squared plus 1. Recall that the quadratic equation in vertex form took on this shape. So from here we can identify, that h here is actually negative 2 and k is actually equal to 1. And a is actually equal to 1. So a couple of things that we can say with the in our analysis is that y equals x squared is shifted 2 units left, 1 unit up. The parabola is opened up in the same direction. Okay, so there is no vertical stretch or compression. So if I were to graph out what this would look like, just really quickly now, what this would look like is something that looks like this. The original parent function, again, has this shape. And what we want to do with this is we're going to shift all the points, right, that are on the parent function. And what will happen to this is all of the points that are on the parent function is going to move 2 to the left and 1 unit up. So the vertex is located at negative 2, 1, and then it's going to take on the same shape as before. All right. Let's take a look at the next example. So here we need to rewrite y equal to x squared plus 8x minus 5 in vertex form, and then we're going to analyze the function. Now, there are actually 2 ways that we can approach this. We can actually identify what exactly is the vertex. So to do this, okay, recall that h comma k is our vertex, right? But also h is really the axis of symmetry. Remember this? So, and then the axis symmetry formula was x is equal to negative b over 2a. So we can find out what that is, okay? So a, or the axis symmetry in this case, okay, is going to be, or h in this case is going to be negative 8 over 2 times 1, or it's negative 4. Now we've got to find out what k is. Well, k is the y-coordinate of the vertex, right? This is the y-coordinate of the vertex. So to figure out what that is, I'm going to take the x-coordinate of the vertex, which is h, and I'm going to substitute it in. So I'm going to say, oh, the function y of -4. And what this means is, okay, I'm not multiplying y with -4. What I'm doing is, what this is saying is, wherever I see x in the original equation, I'm going to replace that with -4. So what this is going to turn into is -4 quantity squared plus 8 times -4 minus 5. Of course, you can use your graphing calculator to, figure out what that y-coordinate is, but, I'm just showing you what the graphing calculator is doing here. So this turns into 16 minus 32 minus 5. So that would be -16 minus 5, or -21, in other words. This is -21. Okay? So the y-coordinate is -21, which seems really, really big. Large and negative, that is, but it's okay. So, the y-coordinate of the vertex is -21, and well, remember the equation in vertex form is a parentheses x minus h quantity squared plus k, right? So we found h and k. We need to know what a is. Well, a is actually the leading coefficient. A is the same as, well, what the leading coefficient was in the original problem. So a is actually equal to 1. So a is equal to 1. So if a is equal to 1, h is equal to -4, and k is equal to -21, then the equation is y is equal to x plus 4 squared minus 21. And then we got to analyze the function, meaning we're going to talk about how is this thing transformed, right, compared to the parent function. So y equals x squared is shifted 4 units left, and 21 units down. There's no vertical stretch or compression. Let's take a look at the next one. Question 3. Alright, so now we got to rewrite y equal to -3x squared plus 6x minus 1 in vertex form, and then analyze the graph of the function. So immediately I noticed that a is equal to -3, b is equal to 6, and c is equal to -1. Right? In order for me to write the equation in vertex form, I gotta rewrite, or I gotta figure out what the axis symmetry is. So it's again -b/2a, right? So because it's -b/2a, I'm going to substitute in b and a in. So this is going to be -6 all over 2 times -3. Alright, so once we have this, this is then going to be +1. So the axis symmetry is equal to 1. I got to now figure out what is the y-coordinate. Okay, so to figure out what the y-coordinate of the vertex is, all I got to do is take the original equation, substitute 1 in, and I get -3 times 1 quantity squared plus 6 times 1 minus 1. So this becomes -3 plus 6, which is +3. +3 minus 1 is +2. So in other words, h and k is 1, 2. And I know what a is. A is equal to -3. So in writing the quadratic equation in vertex form, it's y equals to a times x minus h quantity squared plus k. All I got to do is just make the correct substitutions, and I'm done. So it's y is equal to -3 open parentheses, x minus 1 squared plus 2. Well, I'm not 100% done yet because I'm still left with needing to analyze and graph the function, right? So the analysis is this, okay? The y equals x squared is shifted to 1 unit to the right and 2 units up. All the y coordinates of y equals x squared are multiplied by -3. Actually, I should do this first. This should go in this order. So all the y coordinates are multiplied by -3, then shifted 1 unit right and 2 units up. So when we multiply by -3, okay, the entire graph will be flipped. Entire graph is flipped. Let's try to graph this. So the original looked like this. So the original looked like this. So we're going to take all this and multiply by -3. So how will that look? It's going to look like this. So the vertex is originally at 0, 0. And then it's going to look like this. And then it's going to look like, I'm going to go down to 12. So 2, 4, 6, 8, 10, and 12 is right here. So we have a really, really stretched out graph. Okay? And what are we going to do with this? Well, we are then going to transform this. Okay, we're going to shift this 1 unit to the right and 2 units up. So that means my vertex is going to be located over here. And I'm going to use another color for this. Let's use blue. Actually, let's use green. So the vertex is going to be located there, and then the 2 coordinates is going to be there, and then, so it's 3, 2, 4, 6, 8. It's going to be right here, and right there. So all the points are going to be moved 1 unit. I'm sorry, I got this backwards. It's supposed to be 1 unit to the right and 2 units up. So I got this backwards. 1 unit to the right and 2 units up. So it's going to be here, and then it's going to be here, and then there, and here, and here. So it's going to look like this. Okay? All right, let's take a look at another example. Last question. Write an equation for the parabola whose vertex is at -1, 4 and passes through 2, 1. All right. So here, they're telling us what the vertex is. The vertex is negative 1, comma 1. So this is h and k. And it passes through 2, comma 1, right? So immediately I know that the equation is y is equal to a times x minus negative 1, quantity squared, plus 1. And then I know that it passes through 2, comma 1, which means if I substitute 2 inside of the function here, I will end up with equaling to 1, right? That's the y-coordinate. So if I do this, I put in wherever I see x, I'm going to replace it with 2. And the only unknown I have is a, so I can figure out what a is. So this turns into 3 squared, which is 9. 9a plus 1 is equal to 1. Subtract both sides by 1. I'm sorry. I think I may have miswrote. This should be a 4. It's negative 1, comma 4. So this should be a 4 here. So then that should be a 4. So 9a plus 4 is equal to 1. Subtract both sides by 4. I end up with 9a is equal to negative 3. Divide by 9, I end up with a is equal to negative 1/3. Because negative 3 over 9. So what is the equation for the parabola then? Well, it's y is equal to negative 1/3 x minus or x plus 1, quantity squared, plus 4. That's the equation in vertex form.